Alright, in this video I'm going to be working AP Pre-Cal Homework 2-4, which is mostly about the binomial theorem, but we're kind of getting started, getting on towards reviewing Unit 2, which has been all about polynomials. So we're just going to start by expanding the binomial to write it in its standard form. And it says use the binomial theorem if you want. Now, I'm going to use the binomial theorem on all of these, that are, where it's applicable. But I'm also going to do it, by just multiplying it out the way that I expect that most of the people in my class are going to approach these like third, fourth power situations. But I will show you the binomial theorem way as well if you're interested. So the first one is 2x plus 3 cubed. And so I'm just going to write this out as 2x plus 3 multiplied by itself 3 times. Okay, and then I'm going to just start by doing the first two. All right, so if I multiply those, in my opinion, binomial times binomial is straightforward enough. You've got enough training with FOIL acronym that you're probably going to be able to do it yourself. So I'm not going to make a box for this one. I'm going to call this 4x squared plus outside is 2x times 3. Inside is another 2x times 3. And then the last two multiplies together to be 9. Okay. So that's what we multiplied together for the first two, and now we're multiplying this by 2x plus 3. And now, if I was to collect this, I would have 4x squared positive 12x and positive 9. So I'm going to write that out, set up for a little box multiplication. Okay, I'm multiplying by 2x and a positive 3. So 4 times 2 is 8, 3 powers of x, 24, 2 powers of x, 2 times 9 is 18, and an x. Okay, 3 times 4, 2 powers of x, 3 times 12, 1 power of x, and 3 times 9 with no powers of x. Okay, so now I've multiplied it out. So I might say I've got enough room to say that this is equal to that, which is then going to be equal to, and I'm going to collect like terms along the diagonals, 8x to the 3. And then 12 plus 24 is going to be 36 total x squareds. And 18 and 36, well, 36 plus 10 is 46, and 46 and 8 is 54. So 54x plus 27. Okay, so if you did it that way, that's great. That's perfectly fine. That's honestly what I expect. I'm going to keep the result, and then I'm going to do this again using the binomial theorem. So I think the first thing I'm going to need is the triangle. I'm going to do that each time when I go to start working it with binomial theorem. I'm going to start with a 1 up here, and then 2 1s underneath it, and then to get the numbers, we start with a 1, and then we add the numbers in the middle. So 1, 2, 1, and 1, 3, 3, 1. Okay, that's how far I need to go because I'm taking this to the third power. And so I'm looking for when I see this number there, that's what I know I'm looking for. Like I'm getting this row. Whoops, don't want a blue highlighter, I just want a blue pen. All right, so I know I'm taking 1, 3, 3, and 1. So that's what I'm going to start with. 1 plus 3 plus another 3 plus 1. Okay. Oh, whoops, the original 1 is there. Okay. So then the things that go on the inside is it's going to be, I'm going to take 2x, and I'm going to start by taking that to the third power. Okay, and then I'm going to take 3 to the 0 power, which is going to be 1. Okay, didn't really leave enough room for that. All right, then I'm going to take, and I think I'm going to need to, hold on. All right, that's much better. And so I think I was taking, the second term. And so I'm going to have a power of 2x and a power of 3. Okay, the power of 2x descends and the power of 3 ascends. All right, we're just going to kind of keep that pattern going. Okay, the power of 2x is going to go down to 1, while the power of 3 will go up to 2. And then over here, 2x is going to be taken to the 0th power, and 3 is going to be taken to the 3. All right. So if I take 2x to the third power, I'm going to have 2x times 2x times 2x. That's 3 powers of 2 and 3 powers of x. That's 8x cubed. Okay, over here I'll have 3 times 4, then times another 3. So that's 36. And then 2 powers of x. Okay, over here, I'm going to have it have 9 from the 3 squared. Another 3 makes 27 times 2 is 54. 1 power of x. And then 3 to the third times 1 times 1, that's going to be 27. And so we get the same result. Okay, and so it just depends on, which way would you rather do it. And it's totally up to you. All right, the next one's a 4th power. And I'm going to recommend that you do 4th powers by squaring the square. So I'm going to start by saying, all right, well, x plus 1 squared is going to be x squared plus 2x plus 1. Right? If I do FOIL first, outside and inside, those are both 1x, they add together to 2x. All right, so if I squared x plus 1, I'd have x squared plus 2x plus 1. And if I wanted to square that, well, I might just set up for a little bit of box multiplication and make that happen. X squared, positive 2x, and positive 1. Multiplied by itself. I think you need to listen to me narrate this. All right, fill out the box, collect the like terms. This is going to be x to the 4 plus 2 is 4 total, x to the thirds, 4, 5, 6, x squareds. Oh yeah, I like where this is going. And 4x and 1. Okay, and when I go to do the binomial theorem on this one, I don't think I'm going to pause the video. It's going to be much faster. All right, so we'll go over here and we'll make our triangle. So 1, 1, 1, 1, 2, 1, and I'm going to go until I see 4 because that's I'm taking to the 4th power. So 1, 3, 3, 1, 1, 4, 6, 4, 1. That's the row I'm looking for. So I'll grab that, and I'll have 1, 4, 6, 4, and 1, and this is looking promising, right? Because you can already see the numbers appearing. I'm going to take x to the 4th power, 1 to the 0th power. Okay, and notice that each time I'm just going to be taking a lower and lower power of x while taking a higher power of 1. Power of 1 is just 1, so that's why I'm seeing not much impact here. I've got x to the 4, 4x to the 3, 6x squared, positive 4x, and 1 times 1 times 1, that's going to be 1. Okay, so I'm getting the same result. Okay, so either way, this one's going to be pretty fast. But again, I might recommend squaring the square. All right, 4x minus 1 cubed. Now, this one I think might actually be easier to do with binomial theorem, but maybe I just don't know if that's my own prejudice because I'm pretty fluent with binomial theorem. I'm kind of having a hard time putting myself back in the shoes of a first-time binomial theorem student here. Okay, but what we're going to do is we're going to first start by squaring 4x minus 1, and then we're going to multiply by 4x minus 1 again. Okay, so 4x minus 1 squared, let me do that in red. So that's going to be 16x squared minus 4x minus another 4x and plus 1. So 16x squared minus 8x plus 1. And I guess I will get rid of this here and do a little bit of box multiplication. 12x squared, negative 8x, and positive 1. Multiplying by 4x minus 1. So 4 times 12. Now I can add all of this together and I'll get 48x cubed, negative 44x squared. I wonder if that's right. 32 and 12, yeah, okay. 8 plus 4 is 12. x and minus 1. I'm sure about the first and the last terms. No, 40. What is going on here? Oh, that's why. Okay, I already see the mistake. I copied it wrong. It's 16x squared. Alright, so the error was right here. I just changed that 16, or changed that 2 at 16 like it was supposed to be. That made this a 64 and that a negative 16, so that's going to impact this number and that number. So we need to get rid of those. So get that out and say, alright, I'll have 64x cubed minus, okay, that's more of a number I would expect to see there, 48x squared plus 12x minus 1. Alright, so I'm going to keep that result and check it with binomial theorem. Alright, if I'm making the triangle, I'm going to go until I get the 3, 1, 3, 3, 1, that's it. Alright. One is, first one's not there. Alright, I'm going to be taking 4x to the third power, negative 1 to the 0. Okay, it's good that we've got a negative 1 in here. I don't think I did one like that in class. 3 with 4x getting taken to the second power and negative 1 getting taken to the first. So I see that change of sign. 3 has 4x to the first, negative 1 squared. Okay, again, there's the positive sign. And then 1, 4x to the 0, negative 1 to the third, negative 1 to an odd power is going to be negative 1. Okay, so 4x cubed, it's 4 to the third, x to the third, 4 to the third is 64, x to the 3. 3 times the square of 4x, 3 times 4x times 4x. Okay, so I'm going to do exponents before the multiplication by that 3, because of PEMDAS. So I'm going to have 3 times 16 is 48 x squared times negative 1, that takes care of the negative, that makes it match, plus, okay, 3 times 4 is 12x to the first, negative 1 squared is positive 1, and then 1 times negative 1 is negative 1. Okay, so it matches. Got the right answer. Here's a problem type that I'm not sure you're gonna need, but it's definitely good algebra, so let's do it. I don't think I'm gonna do this one with binomial theorem, though. I don't think that's necessary. So 2 minus x cubed. So 2 minus x squared. Just write it out. Just do this one purely with distribution. So 4 minus 2x minus another 2x is minus 4x, and then plus x squared. Okay, multiplied still by another 2 minus x plus x squared minus 6x plus 9. Okay, I am going to do this multiplication here off to the side, so 4 negative 4x and positive x squared. It doesn't matter if the terms are ascending or descending, you know, as long as we write them in order, and I think stay consistent within the order, then our like terms will still appear on the diagonal. 2 and negative x. But 8. So I'll have negative x cubed plus 6x squared, 12x, and positive 8. Add an x squared, a negative 6x, and a positive 9. I'll have, okay, so the only x to the 3 is that negative 1 there. So in x squareds, I have positive 6 and another one. That's a total of 7x squareds. X's, I've got, whoa. Okay, I didn't count it, but I had written a square there. That should not have been there. All right, x's, I've got negative 12 minus 6 more is negative 18, and just numbers, I've got 8 and 9 is 17. That was kind of a grind. Oh, I didn't even realize it was going off the screen there. Pardon me. All right, there you go. There you have it. Right here, same thing. I'm going to just say this is 3x minus 2 times 3x minus 2 times another 3x minus 2. So, all right, I'll multiply the first two. I'll have 9x squared. 3x times negative 2 is negative 6x. I'll have that again, and then plus 4 multiplied by 3x minus 2. I'll combine those when I go to set up for the box multiplication off to the side. I have 9x squares, negative 12x's, and positive 4. Multiplied by a 3x and a negative 2. Okay, got that. And then I will combine like terms. Let's say I'm going to have 27x cubed. Negative 36 minus 18 more is negative 54x squared. 24 and 12 is 36. X's and minus 8. If we're going to do this with a binomial theorem, then we're going to go over here to the row that says 1, 3, 3, 1, and have 1 plus 3 plus another 3, and then plus 1. Okay, so 3x taken to the third power, negative 2 taken to the 0 power. We're going to let the power of 3x go down and the power of negative 2 go up. Ending with 3x taking to the 0 power and negative 2 going to the third power. Okay, so I'll have 3 to the third, x to the third is 27x cubed. If I have 3x and I square that, I'll have 3 squared and x squared. That's 9x squared times 3 is 27x squared times negative 2 is negative 54x squareds, and then, okay, 3 times 3 is 9x times 4 is 36x. Then all of that times negative 2 to the third is going to be negative 8, and okay, that's the same answer. Here, 3x plus 4 squared plus x minus 1 cubed. All right, I'm just going to set this up. Oh, wait, no, I just copied the problem. 3x plus 4, just write it out twice, and then the x minus 1 I'm going to write out 3 times. And then I'm just going to multiply 2 at a time, just kind of sticking to what I'm good at. So 9x squared plus 3x times 4 is 12x, but there's going to be a second one, so it'll be a total of 24x's and 16 plus, and then if I multiply 2 of those together and then save for the third, I'll have that. You know, a different way you can go, I think probably how I was instructed to multiply stuff like this a long time ago, was just like distribute the x over the whole polynomial, right? So I'm going to distribute the x over the x squared. So x to the 3 minus 2x to the 2 plus 1. And then add distributing negative 1 over the polynomial. So negative x squared, positive 2x, and negative 1. Okay, so now I'll have all the terms I need. I just need to combine them. Okay, so for x to the 3's, I only have one. X squareds, I have 9. minus 2 is 7, minus another one is 6. For x's, I have 24, plus 2 is 26x, but I messed that up. Hold on, this doesn't look right. Yeah, okay, when I distributed the x, I had an x times plus 1 there was. So this is not the right number there, or the right thing at all. It's going to need to be a plus x. This doesn't look quite right. Yeah, that's much better. Okay, so now I'm going to have 24x plus an x is 25x's plus 2 more is 27x. And then for just numbers, I've got 16 minus 1 is 15. All right, that was number 1. Number 2 is use the binomial theorem to fully expand the polynomial. All right, so I'm definitely going to do that for x plus 2 to the 5th power. But I think for 3x minus 2, I'm going to square it twice because I just really want to reemphasize, like, we really don't think you're going to have to go higher than 4th power in AP Pre-Cal. And moreover, we think y'all are strong enough in algebra that you can just square something twice and come out with about the same amount of computation time and possibly a little bit more reliable than trying to use Pascal's triangle. Yeah. So use the binomial theorem to fully expand the polynomial. So 5th power, so I'm going to set up the triangle. Let's enlarge that a little bit. Let's keep going. There we go. 1, 5, 10, 10, 5, 1. That's what I'm looking for. And because this one's starting to get a little big, I think I'm going to align this vertically. I remember the last time I taught binomial theorem, I think it was in college algebra class, where we actually needed to be able to like really kind of fluently work with this. I think that was what I did was I aligned my work vertically and then collected like terms at the end and put the work below. That's kind of occurring to me now. So we, had these various powers of x. Yeah, this was a pretty nice way to do it. Okay, and then we had positive 2. And in fact, I think I always made sure to put the plus 2 there inside the parentheses to remind that, like, if it was a minus, we would put that in there too. And it would still be in the parentheses, and we're still multiplying the stuff together because what we're actually adding on is the numbers in blue. Okay, and so we're going to start with the 5th power, and the power of x is going to go down. Power of 2 will go up. And what's actually nice about this is, because of the symmetry of this whole situation, it doesn't matter if you start the x with 5 and go down, or start the x with 0 and go up, just as long as you start one at 5 and the other one at 0, and then descend one and ascend the other, good to go. Okay, so that's kind of something that's nice about it. Okay, and then I like to multiply out the terms here, so I'm going to have an x to the 5. 5 times 2 is 10x to the 4th. 10 times 4 is 40x to the 3rd. 2 to the 3rd is 8 times 10 is 80x squared. I feel like we did this one in the notes. Because I think it's going to be 80 again, right? Yeah, 2 to the 4 is 16 times 5. Yeah, I've done this a couple times today. Okay, so another 80 and x, and 2 to the 5 is 32. Okay, so if I were to write this out all the way, I'd have an x to the 5, 10x to the 4, 40x to the 3, 80x to the 2, 80x to the 1, and 32. Alright, this thing is going to be not too bad. We're going to square 3x minus 2. X squared minus 6x. I feel like we've already done this one too. minus 6x plus 4, but I guess we're mostly sticking to like, 1s, 2s, and 3s, and so the numbers are going to seem somewhat repetitive. Okay, and so that's 9x squared, negative 12x, and positive 4. So if I'm going to square that, that's all much room. Right. 12 times 9 is 108. If 108. Okay, yeah, that doesn't make sense. There's definitely going to be some symmetry here to where, like, I don't know, if you just did 1/2 of it, you could probably have it figured out. If you figure out some sort of shortcut or trick, let me know. I'd be kind of interested to see it. 12 times 12 is 144. This thing has got a lot of symmetry to it. That's 4 times 4 is not 36. All right, there we go. So I've got it all. I'm going to write it down, be done. So 81x to the 4 minus 216x to the third. Cool. In terms of x squareds, I'm going to have 72 plus 144. Is that 216 again? Not sure. Does feel like it. That's going to be plus 216x squared minus 96x and plus 16. Okay, so that was a little intense. But still wasn't. It still pretty much stayed within the realm of like times table arithmetic, and not too much worse than that. All right, so let's make this happen with the binomial theorem. There we go. You can see it now, but it's 14641. We've made this quite a few times at this point. All right, so I'm going to have a 1 plus 4 plus 6 plus 4 and plus 1. The actual terms are going to be some power of 3x and some power of negative 2. The power of 3x go down, power of negative 2 go up. And then, okay, then take 3x to the 4th power. That's going to be 81. Actually, I'm not going to do that. X to the 4. Okay, 4 times 27 times negative 2. Oh, that's tough. Okay, so 8 times 27, and it's going to be negative, so minus. Now, I mean, I know it's going to be 216, but what I can do is I can borrow one of the 3's from the 27 and make that 8 times 3 is 24. I still don't like that. What's that going to be? I guess it's 8 times 20 is 160, and 56 is 216. I don't know how else to explain that on an arithmetic level. I can see that it was going to be the case. I thought I was going to be able to like borrow from the 27 and make it. I'm sure you can make it 12 times 8, or not 12 times 8. Well, I guess that's the issue, is I don't have anything that goes up to 216. Okay, anyway. Oh, I was going to make it like this something's third power. Yeah, 6 to the third. That was the idea. Okay, anyway. With the third row, I've got 6 times 9 times 4. So 6 times 36, that's also 6 to the third, that's 216. And all three are positive because the negative 2 is getting squared. So positive. Okay, negative 2 to the third is 8, and 12 times 8 is 96. Power of x, and then the last term is going to be negative 2 to the 4th power is positive 16. Okay, there we go. Use the binomial theorem. All right, now the next few questions are going to seem probably pretty lightweight by comparison because we're just going to ask you some trivia questions about these functions. Okay, so, here's a polynomial. It's 2x times x minus 3 times x plus 4 squared and 3x minus 5 also squared. Okay, so we're giving its factored form. The degree of the polynomial, what we're going to do is we're going to add up all the powers. Okay, the 2x is one power, x minus 3 is another power, x plus 4 and 3x minus 5 are both squared, so if I was to multiply those out, they would have an x squared in them. If I add up all those powers, that's how many powers of x total I would have if I went through and multiplied all this out, which we definitely are not going to. We've done enough of that today. So we're going to see 2, 4, 5, 6 total. The degree of polynomial is 6. I'm going to need a much thicker pen. All right, now the leading coefficient is going to be, what's going to happen with all of these? I don't really want to write it out in terms of just the leading terms because that's what I'm actually doing here. But that would be bad algebra. So the leading coefficient is going to end up being 2 times 1 times 1 squared times 3 squared. I think that's about as much as I'm comfortable writing. So 2 times 9 is going to be 18. None of those things are negative. Yeah, that's what I'm going to do. That's how I'll write it. Then the zeros with their multiplicity. Okay, 2x gives me x equals 0. That's a single root. Okay, x minus 3 is going to give me x equals 3. Also a single root. X plus 4 squared would be x equaling negative 4, but since it's squared, that's a double root. And 3x minus 5 squared, all right, 3x minus 5 would equal 0 when 3x equals 5, which is when x is 5 divided by 3. And that one's squared too, so it's also a double root. Okay, now, because it is an even degree polynomial with a positive leading coefficient, it's 18x to the 6, and a bunch of other stuff, it's going to look, at least on the outsides, like the graph of y equals x squared. Okay, so from both sides, the graph is going up. So as x approaches infinity or negative infinity, y is getting bigger and bigger, y is approaching positive infinity. Sketch the graph of f, why not? We've done that a little bit this unit. So, okay, I'm drawing myself an x-axis. Then I will label it with the zeros. So I've got one that's negative, one at 0, one at 5/3, one at 3. All right, and now I'm gonna just go, I'm not gonna make the sign chart. Actually, probably I will, but I would normally just start with the end behavior and be like, all right, look at this. Starting from the outsides, it's coming like this. X equals negative 4 is a double root. X equals 3 is a single root, so pass through that one confidently. Bounce over here. X equals 0 is a single root. X equals 5/3 is a double root, so it's gonna fit just right. And there we go, we've got ourselves a sketch. Okay, I'm gonna come in and do the y-axis, but I didn't forget about the, oh, whoops. It's supposed to be snapping to a shape, but that will. Oh, I don't know if that even helps at all. That was supposed to be my y-axis. Okay, so, but what we could also have done is chosen a test point out here, like, I don't know, x equals 10. Okay, and so when x equals 10, say, all right, f of 10 is 2 times 10 times 10 minus 3 times 10 plus 4 squared, that's definitely positive, and 30 minus 5 is 25. If I square that, that's certainly positive. I have positive here, x equals 3 was a single root, x equals 5/3 was a double root, so there's, wait, it's a single root, so that meant there was going to be a sign change. And a double root, there will not be a sign change. X equals 0 is a single root, so the sign will change, and then x equaling negative 4, that was also a double root, so no sign change. Okay, and that confirms what I see on the graph. All right, the next one is another factored form polynomial, 2x cubed times 2x plus 1 squared and x minus 3. All right, so the degree of the polynomial, I would add up all the powers of x. I see 3 powers of x from 2x cubed, 2 more from squaring 2x plus 1, so it's a total of 5, and then x minus 3, that's a 6th degree polynomial. The leading coefficient is going to be negative 2 multiplied by 2 squared multiplied by 1 to the first power. Okay, just multiplying the leading coefficients of all the terms in the factored form. That's going to be negative 8. And the zeros with their multiplicity would be x equals 0, multiplicity 3, or we could call it a triple root. X equals, that would need to be negative 1/2 for 2x plus 1 to equal 0. That's going to be multiplicity 2. And then x equals 3, and that's going to be multiplicity 1, so I'm just not going to write anything, because it's just a regular 0. All right, as x approaches negative infinity, okay, I need to think about the end behavior of this thing, and so that's going to be, okay, 6th degree polynomial, an even degree with a negative leading coefficient, looks like y equals negative x squared. Okay, so from both sides, y is going down, approaching negative infinity. And then sketch the graph of g. Okay, so I'll start with an x-axis. I will label it with my zeros. Be x equals 0. I've got a negative 1 and a positive 1. Okay, so negative 1/2. And x equals 3. X equals negative 1/2. That's the double root. That's going to be the one that has a bounce. But I also have a triple root, x equals 0, so I'm going to label that one as a triple root so I can remember to make sure that the graph hesitates as it goes through that 0. All right, and then I'm going to otherwise just use the end behavior to sketch my graph. Okay, so I know that it's coming from below and then going down. So I'm going to start with my arrows and like how that fits, about like that, and then down there. And I just need to make sure that my graph fits in with the zeros and the multiplicity, and then I will know that it works. Okay, because if I can't make it work, or if I've got to have another 0 that's not otherwise planned for, I know I've done something wrong. It made it hesitate as it went through there, and then it's going to be a confident pass through, and there we go. Okay, that's as good as we're going to need. All right. Give a y-axis, that will work. And there we've got ourselves a really nice graph, so sketching the graph of g. All right, looks like I think we've got 2 more of these, but both of these are going to be ones we'll need to factor ourselves. Okay, so it's going to ask about the degree and the leading coefficient. Okay, these are information we see from the high power term, right? This is negative 3x cubed, and that's not what I expected to happen. Maybe that'll work better. I'm not sure what's going on here. Okay, you know what I mean. I want that term. All right, so from that high power term, we are going to see the degree, and that is the exponent. That's the 3. And then the leading coefficient, that will be the actual coefficient that we're multiplying by. I also see why that was happening. That's going to be negative 3. Okay, the zeros with their multiplicities. We're going to have to factor this thing if we want to have any shot of finding those. Okay, so I'm going to factor out a negative 3 and an x from each term. And I'll be left with a 25, a positive 10x, and an x squared. And I don't know, maybe that's recognizable to you, but I'm going to rewrite that so it might be something you think is a little better. But all I did was rearrange the order I added stuff in, and 4 plus 3 is the same as 3 plus 4, so there's nothing wrong with that. So I go and I have it like this, and okay, the thing in parentheses, I can keep factoring that. And it's important to remember what we're trying to do here. is factor it so that we can find the zeros. So often in this homework we've been trying to actually distribute it out. It would be a shame if you went and distributed it back and got negative 75x, negative 30x squared, and negative 3x to the 3. We already knew that's what d of x was equal to. So if I factor x squared plus 10x plus 25, looking for two numbers that multiply to 25 while adding to 10, that's going to be 5 and 5. Okay, so I could write that as x plus 5 squared. So zeros with their multiplicities, negative 3x could equal 0. That would be if x was equal to 0. And that's going to be multiplicity 1. And then I'll have x equaling negative 5, and that'll have multiplicity 2 because it's there twice and it's squared. Okay, now the limit, so it's a negative leading coefficient on an odd degree polynomial, so it'll look like negative x cubed. So as x approaches negative infinity, that's the first one it asked for, what's happening as we move to the left, the graph's going up. D of x is getting larger and larger, and it's going towards positive infinity. And as x approaches positive infinity, d is approaching negative infinity. All right, so I'm going to sketch the graph of d, and that's negative 3x times x plus 5 squared. Just zoom in on that a little bit. All right, there we go. All right, so I think I might make a sign chart for this one, although if you want to say, all right, it's a third degree polynomial with a negative leading coefficient, so I know it's going to start from above and eventually go down, good for you. That's perfectly valid. Okay, so I know my zeros are at x equals negative 5 and x equals 0. Yeah, I'm going to make a sign chart. I'm going to use a test point. I'll use x equals 1. So if I plug in 1, I'll get negative 3 times, so maybe I'll say negative 3 is a negative number, times 1, which is a positive number, times 1 plus 5 is 6 squared is definitely going to be positive, so that's negative. So I'll put that over here. X equals 0 is a single root, so I'll see a sign change. And x equals negative 5 is a double root, so I'll see no sign change. And say, all right, well, that means that the graph's going to be coming from above. It's going to be positive. It's going to bounce here. Just don't like that graph. I'm going to try that one more time, but if this isn't any good, then I'll just live with it. That's not as bad. I think that's all right. Okay, so there we have it. And, you know, we can draw in a y-axis if we like. And then we have ourselves a really nice sketch. All right, now this last one, I remember we were talking about this, and this is a little crazy. I don't think this would ever happen, like from any of the College Board stuff, but I think, you know, it's good to point out and just really remind you that this is something we should probably be aware of. That, you know, we're looking for the highest power term, and that can appear anywhere, right? Even in the middle, maybe. So, I think the first thing I want to do here is rewrite k of x into a more standard form. You know, if you prefer to write your polynomial in ascending power order, great, nothing wrong with that. It's definitely a time where we're going to want to do that in the future. But for now, I don't think it really matters. We just probably want to be systematic about it and do whatever's most comfortable to us. All right, so I've got that. I should probably just go ahead and factor. I'm going to say I've got negative 3, because I definitely want to get rid of that negative out of the leading term, and 2 powers of x. So let's say multiplied by x squared. No, not plus. I multiplied negative 3x squared by a negative x to get positive 3x to the third. And then negative 20 to get positive 6x squared. Yeah, and then that thing in parentheses, I'm going to be able to factor that. That's going to be like a 5 and 4. I think negative 5 and positive 4. Yeah. Okay, so now that I've got it, I could probably have just started with the degree and the leading coefficient. The degree is the highest exponent I see, and the leading coefficient is the number that's multiplied against that highest power of x. Okay, the zeros with their multiplicity, I'm going to have x equals 0, which is a double root x equals 5, which is a single root, and x equals -4, which is also a single root. Okay, an even degree polynomial with a negative leading coefficient, that's like -x squared. Okay, I'm gonna have that. Okay, so both of these are going to go to -infinity. Now, I think I've got all the information I need to sketch the graph right here on the screen. The zeros and the multiplicity and the end behavior. Okay, so I'll sketch the graph starting with an x-axis, 0, -4, and +5. Okay, so I have one double root, and that's at 0. The other are single, so I'll just kind of mark that. I know that it's coming from below. X equals 4 is a single root, or x equals -4 was a single root. Then x equals 0 is a double root. And it fits just right. Okay, I've got that. You know, if you want, definitely not mandatory, you can sketch a graph through here. I mean, sketch a y-axis if you like, and label your axes. If you don't want to, no judgment. Okay, that's a good sketch. And I think that's all for this problem set. Okay, so that's all for homework 2-4. Thanks for watching. Hope this helped.